And this quadratic equations we have already seen in our earlier discussions, where we have real coefficients and real roots. And what we are discussing today is the complex coefficient and what are their solution in the complex number system. Let us go back and revise first. The real polynomial, that is fx is equal to a0 plus a1x till an x to the power n. Now here this a0, a1, if they are real numbers, these are real numbers, and x is a real variable. So this is called a real polynomial of real variable x with real coefficients. For example, we have x square minus 4x plus 3. Now if this a0, a1 until an, these are complex numbers. These are complex numbers, and x is a varying complex number. X is a varying complex number. So this fx equal to a0 till an, this is called a complex polynomial, or a polynomial of complex variable with complex coefficient. For example, we have this as 2x square minus 3 plus 7i into x plus 9i minus 3. So the coefficients are also, these are complex numbers. So these are complex polynomials. So what is the degree of a polynomial? Remember, what is the degree of polynomial? For example, this is 2x cube minus 7x square plus x plus 5. So the highest power which we have is the degree. Here the degree is 3. So whenever we have a degree of 2, we call it as a quadratic polynomial. Whenever we have polynomial of degree 3, we call it as a cubic polynomial. Whenever we have a degree of 4, we call it as a biquadratic polynomial. Right? So if fx is a quadratic polynomial, when fx equal to 0, then we call it as an equation. Quadratic equation is what? We have ax square plus bx plus c. When it is equal to 0, there is an equality sign. So we call it as a quadratic equation. So the roots are there for an equation. What is the root of the equation? Whenever we put x here, for example, I'll take an example. X cube minus 6x square plus 11x minus 6 equal to 0. Now if you put x equal to 1, it will be 1 minus 6 plus 11 minus 6, and this is 0 equal to 0. So x equal to 1 is actually the root of this equation. Now similarly, if you say x square plus x plus 1 equal to 0, so omega and omega square, you know about omega. So these are the solution of this. These are called the roots. So when we talk about solution set of all roots of an equation in a given domain, this is called a solution set of the equation. For example, if you take this, x equal to 1 also satisfies it, x equal to 2 also satisfies this equation, and then x equal to 3 also satisfies this equation. So the solution set is 1, 2, 3. Solution set is 1, 2, 3, because all 1, 2, 3 satisfy this equation. There is one more thing, which is the identity. Identity, that is, if you write x square minus 9, you know the formula, x square minus 9 can be written as x square minus 3 square. So you can write it as x minus 3x plus 3. So x minus 3x plus 3. This means an expression involving equality and a variable is called an identity if it is satisfied by every value of the variable. Even if you put, say, you put 1 here, 1 minus 9, you put 1 here. So you get minus 2 into 4, and this is minus 8. So minus 8 equal to minus 8. So this is called as the identity. So there is a fundamental theorem in algebra. Every polynomial equation of form fx equal to 0 has at least one root, real or imaginary. It can be real, it can be complex also. This is the fundamental theorem of algebra. But if you take fx equal to root 3 plus x equal to 0, now this has no root, as this equation is not a polynomial equation. This is not a polynomial equation. Fundamental theorem does not apply to this equation, though it applies to this equation. Every polynomial equation with fx equal to 0 of degree n, if the degree is n, then it will have exactly n roots. It may be real, it may be imaginary or complex. So let us go back how we are going to find out the quadratic equation with real coefficient. We have learned that if we have equation, this quadratic equation ax square plus bx plus c, then we have solved this quadratic equation with real coefficient and real roots, this either by factorization or either by using Sridharacharya formula. So we shall mainly concentrate on quadratic equations with real coefficient and complex roots. First of all, let us see how we are going to solve it. Let us multiply both sides by a. So when you multiply a, what do we get? A square x square plus abx plus ac equal to 0. Now a square x square plus abx equal to minus ac. We are taking it here. Now add and subtract b square by 4 here and b square by 4 here. So what do we get? This is nothing but ax plus b by 2 whole square. And this is b square by 4 minus ac. Now let us solve it. This is b square minus 4ac by 4. Now take this square here as a root. This will be plus minus under root b square minus 4ac, and this is 1 by 2. 4 comes out. So this becomes ax plus b by 2 equal to this one. Now take b by 2 here. Ax will be equal to minus b by 2 plus minus 1 by 2 under root b square minus 4ac. Now you can write this as ax as minus b plus minus under root b square minus 4ac by 2. Since we have 2, both has 2 as the denominator. Now put this a here, take this a here. So this x become minus b plus minus under root b square minus 4ac. So alpha is what? When you take plus sign, beta is what? You take negative sign. So we have alpha and beta, these are the root of this equation. These are the root of equation. So this b square minus 4ac is the basic thing. Now this will decide what type of result we are going to get. This is called the discriminant. This is called the discriminant. Discriminant will decide what kind of result we are going to get. Let us see what are the results we get. So the first result we get when b square minus 4ac is equal to 0. So when determinant is 0. So we have minus b plus minus under root b square minus 4ac by 2a. Now this is 0. So you will get minus b by 2a, alpha also and beta also as minus b by 2a. So b square minus 4ac, if b square minus 4ac is equal to 0, that is determinant is 0, the quadratic equation will have real and equal roots. Equal roots, and both are equal to minus b by 2a. The second result comes here is if a, b, c for ax square plus bx plus c equal to 0. If a, b, c are rational numbers, these are rational numbers, and b square minus 4ac is positive and a perfect square, that is if this is under root 4, it is a perfect square, 2 will come. So if it is a perfect square, then b and this under root b square minus 4ac, this is a rational number. So alpha and beta will be a rational number and they are unequal. So if a, b, c belongs to Q, rational number, b square minus 4ac is positive and a perfect square. So roots are rational and unequal. Similarly, if a, b, c of this equation, quadratic equation, belongs to real number and b square minus 4ac is positive and a perfect square, then the roots will be real and distinct. Real and distinct. So this is the second result. Now let us come to the third result. Now third result, if b square minus 4ac is greater than 0, that is the determinant is greater than 0, but it is not a perfect square, then the roots will be irrational and unequal. For example, see if we have, and they always come in conjugate pair, like 2 plus root 3. If this is the root, the other root will be 2 minus root 3, right? So if a, b, c are irrational number, if a, b, c they are irrational number and b square minus 4ac, d is positive but not a perfect square, not a perfect square, then the root may occur in conjugate pairs. They may not occur in conjugate pairs if this is the case. For example, if you have say equation like x square minus 5 plus root 2 x and plus 5 root 2 equal to 0. So the roots are 5 and root 2 and they do not form a conjugate pair. Let me tell you again, if a, b, c, they are irrational and b square minus 4ac determinant is 0, is positive but not a perfect square, then the root may not come in conjugate pair. This is an example. There is one more result. The result is such that b square minus 4ac is less than 0. So when b square minus 4ac is less than 0, then the roots are complex conjugate of each other. In fact, the complex roots of an equation with real coefficient always occur in conjugate pair. For example, 2 plus 3i, the other will be 2 minus 3i. However, this may not be true in case of equation with complex coefficient. For example, x square minus 2ix minus 1. This equation has both roots as I, not like this, conjugate pairs. Now coming to the quadratic equation with complex coefficient. So we already know that we have an equation like ax square plus bx plus c. So now we know that alpha and beta is simply minus b plus minus under root b square minus 4ac by 2a. Alpha is if you take plus sign, beta is if you take negative sign. So these roots are complex as a, b, c are complex. When we take this a square plus bx plus c equal to 0 and when we say a, b and c, these are complex numbers. These a, b, c are complex numbers. So alpha and beta, these are the roots, and a, b, c are complex numbers. And roots are also complex. Alpha and beta will also be complex. And since the order relation is not defined in the case of complex number, therefore we cannot assign positive or negative sign to the discriminant d equal to b square minus 4ac because the order relation is not defined in case of complex numbers. But this equation has complex roots which are equal if this d b square minus 4ac, this is 0. This equation will have complex numbers which are equal if d b square minus 4ac is equal to 0 and unequal roots if this is not equal to 0. I'll just take an example. One more thing is there. In case of quadratic equations with real coefficient, imaginary, that is complex roots, always occur in conjugate pairs. But it is not true for quadratic equation with complex coefficient. For instance, this 4x square minus 4ix minus 1 equal to 0 has both roots equal to half I. Let us take an example how to solve it. I'll just give you one example because when we are going to take the problems, we are going to understand it better. So x square minus 5ix minus 6 equal to 0. So these are the quadratic equation. Let us solve it by factorization method. So x square minus 5ix, I am writing this as plus and this has 6 into I square. Why I square? I square is minus 1, so minus will come here. So I can write it I square. So I can write it as x square minus 3ix minus 2ix plus 6i square equal to 0. Now let us take x common, x minus 3i. Now let us take 2i common, minus 2i, x minus 3i. So this will become x minus 2i and x minus 3i. So x will be equal to 2i and x will be equal to 3i. And we will solve certain equation by the Sridharacharya formula also, that is minus b plus minus under root b square minus 4ac, and we will see how it comes and how it unfolds. So this is about the complex. We discuss about the previous stuff we already know, and we discuss about how we are going to go about with the complex A, B, C and the complex result.